Okay, so we just talked about why soil is important, how it is made, and how long it takes soil to form. So let's look at some specific soil properties. All right. Now, this picture right here is showing us the different layers of soil. Now, in environmental science, it's a little bit fancy right here. We don't call them layers. They are called horizons. So we're going to look at the different horizons of soil. So as soil develops, it creates horizons. All right. So let me scroll back up here a little bit. There we go. All right. So as soil develops, it creates horizons. And look, y'all, I went back to my original tablet, so my handwriting's better. Okay. So we categorize the layers basically by what they're made of or what they're composed of and what organic material they contain. So layers are categorized by composition, and organic material. Okay, so we're going to start at the top. We're going to work our way down. All right, so we have the O, A, E, B, C, R. Now, yeah, y'all got to remember these in order, and I apologize for that, but I always like to give people tips to help you memorize things like this. So there's an acronym that people use to remember what the layers are in order. So the acronym that will help you remember is, let's write it down. Onions are eaten best cooked right. Okay, onions are eaten best cooked right. So O, A, E, B, C, R. Okay, those are the layers of soil, or the horizons of soil, in order. So top to bottom. Okay. So let's start at the top one. The O horizon is loose and partially decayed organic material. Yes, you got to know this whole thing right here. Loose and partially decayed organic material. So this is going to be basically what we see as the surface of the ground. The next one we have is a horizon. So this says mineral matter mixed with some humus. Now, y'all, I know this looks like hummus. And probably I called it hummus before I knew what it was. But this is not hummus, it's humus. So what is humus? No, it's not the stuff that you eat, okay? Humus is decomposed animal and plant matter. That's definitely not what you eat. Decompose animal and plant matter. Okay, so a horizon is what contains our humus, and this is what we call topsoil. Okay, so the A horizon is topsoil. All right. The E horizon is light-colored mineral particles, zone of eluviation and leaching. So what this means, the leaching part, okay, this is the layer where toxins are filtered out. So I told you guys that soil does a really good job of filtering water. So the E horizon is specifically where it filters out toxins, so it does not get into our groundwater. All right. The B horizon is accumulation of minerals transported from above. This layer right here has very little organic compound. So as you can see, the deeper in the ground we go, the more compact it becomes and the less organic material there is. So that's why roots really can't penetrate past the A horizon, because the soil is just too compact and dense. So the C horizon is partially altered parent material, and then we have the R horizon. This is the unweathered parent material, the bedrock. Okay, so remember, parent material is what the soil comes from, what it's made from. So the R horizon is legitimately rock. Okay, all right, so moving down here, this is where we see our 3 different types of soil particles. All right, so we have 3 types of soil particles, and you guys are actually going to do an online lab about this. So we have sand, silt, and clay. Now, you guys have heard of sand and clay, but silt is a really important component of soil because this is where a lot of the nutrients are that are going to help support agriculture. Now, what you need to understand, though, is the size of the particles themselves. Okay, so here we have soil particle size. So we have sand, silt, clay. So let's look at the picture. What's the largest? Sand. What's the smallest? Clay. And in the middle, you've got silt. Now think about it, guys. If you've been to the beach, or if you haven't been to the beach, hopefully at some point you've held sand in your hand. You can actually see the individual grains. Sand is a very large particle when it comes to soil. So, in order to have a really good soil type, especially for agriculture, you want it to be a really good mixture of all 3 of these. Okay, and the reason is you want to look at the porosity of the soil. So let's look at this picture right here. So porosity, look, it literally means airspace between the particles. Okay, so with sand, you've got big chunks of space. So let's say if you pour water through sand, what's the water going to do? It obviously is going to go straight through it because soil doesn't hold itself together. It doesn't compact. Okay, so water flows straight through it. Now, when you get to clay, which is the smallest one, there is very little porosity. So clay is going to hold on to water. It's not going to let it move through it. Silt, the medium one, there are medium-sized spaces, and so it does allow a little bit of water to move through it, not as much as sand, and then it lets a little bit more out than clay. So what we want right here is a combination of all 3. Okay, we want soil to be able to retain water and also let an excess amount of water flow through it, because we know that when plants get too much water, they die. Okay, so what this directly leads to is what we call permeability. All right, so permeability is the measure of how easy water moves through soil. Okay, so which one of these is going to have the highest permeability? Sand, right? It's going to allow the most amount of water to go through it. Clay has very low permeability because water can't simply flow through it. So hopefully you guys understand the difference between the sizes of the soil particles and why it's important to have a combination of all three. We want to be able to retain enough water to keep the plants alive, but allow excess water to leave. Okay? All right. Now, this is what we call a soil triangle. So, what farmers do if they are moving into a new location, they need to be able to identify what specifically the soil is made of and what the type of soil is, because they need a specific type of soil in order to grow plants. So the soil triangle allows us to identify the type of soil. So it allows the identification and comparison of soil types. And this is going to be based on those three soil particles. So it's based on the percentage of sand, the percentage of clay, and the percentage of silt. Okay? All right. So the way that you read this is you have to look at the axes. So there are 3 axes. So here we have sand, and we have silt, and we have clay. Okay? So let's say, for example, and guys, you're going to be given problems on the AP test about this, and you are going to have to figure it out. So you will be given the soil triangle. They'll give you the percentage, and then you have to figure out what type of soil it is. And I'm going to give you guys some examples to do for practice. So right here, let's do this one. 40% sand, 40% silt, and 20% clay. What type of soil is that? Okay, so I always start with sand just because it's on the bottom. You can start wherever you want to because you're going to get the same answer. Okay, now you can see that the lines run in 2 different directions. All right, so 40% sand. Here's our 40% sand. Okay, and then it says 40% silt. All right, so 40% silt. So what I'm going to do is I'm going to draw a line to where the 2 40s meet right here. Okay, 20% clay. Here's my 20% clay. I'm going to go right here. So it lands in this purple box, which is loam. Okay, so this type of soil is what we call loam. And loam is actually what we want for farming. This is the best for farming, okay? Because it contains the right amount of sand, silt, and clay, meaning it is able to hold on to enough water to keep the plants alive and well, while allowing itself to drain excess water when it's there, so we don't have flooding and we don't have oversaturation of the roots. Okay, so it's important that we understand water retention contributes to land fertility and productivity. There's that photosynthesis word, okay? Remember, productivity is photosynthesis, okay? So, what I'm probably going to do is find another video for you guys to watch about how to do soil triangles so that you can see lots of examples.